Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to talk about sequence of numbers. Sequence of numbers is just numbers. Yeah, it consists of numbers that we write, okay, according or arrange following certain rules or certain formula. Sometimes we call it following certain formula. Okay. Now, in general, we can write a sequence like this by using symbol A. So we have A1, we have A2, A3, and so on up to AN, and then can continue, goes to infinity. So A1, okay, is called the first term, right? A1 will be the first term, and A2 will be the second term. Okay. Now for A3, the third term, and so on and so forth, right? So all these are called terms. Okay, the first term, the second term, the third term, and so on. Now, our sequence, okay, maybe the terms of the sequence, okay, stop. For example, like this one, where we have A1, then we have A2, then we have A3, up to AN, and then the terms of the sequence stop, or we call it terminate. Okay, then we call this type of sequence as finite sequence. Okay, finite sequence. Okay, for example, if we have a sequence like this, 2, 4, 6, 8, and then 10. After 10, there is no other terms of the sequence. Okay, after 10, the sequence stop. So we call this type of sequence as finite sequence. Okay, on the contrary, sometimes we also have what we call infinite sequence. Okay, for example, if we have A1, the first term, A2, the second term, the third term, and so on, what we call the sequence goes to infinity, meaning to say the terms of the sequence never ending. Okay, goes forever, goes to infinity. Okay, this type of sequence we call infinite sequence. Infinite sequence, right? For example, we have things like this. We have 1, 3, 5, 7, okay, and this sequence goes to infinity without ending. Okay, the sequence of odd numbers, 1, 3, 5, 7, and then 9, and then 11, and so on and so forth, goes to infinity. So this type of sequence we categorize as infinite sequence. Now let's see our example here, writing sequence, writing terms of the sequence. We are given the what we call the nth term, an given, that is equal to 2n plus 3. So the question is asking us to write the first three terms of the sequence. Okay, so meaning to say we are going to find the first term, the second term, and the third term only, because the problem is asking us to write down only the first three terms. So we want to find A1, right? So A1 is equal to, we substitute n equal to 1. So 2 times 1 plus 3, this is 2 plus 3, this is equal to 5. Okay, that would be our first term. Now for the second term, when n equal to 2, so we follow the same formula, that is 2 times n, this time is equal to 2, still plus 3 is equal to 2 times 2 is 4, 4 plus 3 is equal to 7. Now for the third term, we have to find what is our A3 equal to, we still use the same formula, 2 times n in this case is equal to 3, so 2 times 3 plus 3. So 2 times 3 is 6, plus 3 is equal to 9. So now we can write down the first three terms of the sequence. That is, we start with 5, the first term, and then we have 7, the second term, and we have 9. Okay, the third term. Actually, the sequence goes forever to infinity. But, okay, this problem is just asking us to write down the first three terms. That is 5, 7, and 9. So now let's continue with this example. That is, we are asked here to write down the first three terms, okay, of the sequence that is given in terms of its nth term, that is given an. Okay, this formula is given to us. An equal to -2, okay, -2 to the power n minus 1. So we want to write down what is our a1, what is our a2, and what is our a3. So let's write down when n equal to 1, that is we want to find the first term, a1 is equal to, we just follow the formula, we have -2 to the power n minus 1. So in this case, okay, for the first term, n equal to 1. So 1 minus 1 equal to -2 to the power 1 minus 1 is 0, right? So -2, anything to the power 0 is equal to 1. That will be our first term. So first term is equal to 1. Now for the second term, that is a2, a2 equal to -2 to the power n minus 1. Okay, this time n is equal to 2. So 2 minus 1. That is -2 to the power 2 minus 1 is 1. Anything to the power 1 is that thing. That is in this case is equal to -2. Now for the third term, we have to find what is our a3 equal to still -2 in bracket n minus 1. That is n in this case equal to 3. 3 minus 1. So -2 to the power 3 minus 1 is equal to 2. -2 square is equal to 4. Okay, so these are all our first three terms. Okay, the first three terms of the sequence is this. That is 1, -2, and 4. So now we are ready to write down our terms of the sequence. So we have 1, we have the second term is -2, the third term is 4. Okay, that's the first three terms of this sequence, and the sequence goes to infinity like this. Now let's proceed to the next example here. But in this case, our sequence involve what we call factorial. So now, before we solve this problem, we want to review, okay, what we mean by factorial. Okay, 0 factorial is equal to 1. Okay, in one of my video, I already explained why 0 factorial is equal to 1. Okay, those who are interested can watch that video. 1 factorial is equal to 1. Okay, 2 factorial is equal to 2 times 1. 3 factorial is equal to 3 times 2 times 1. Alright, you see the number that we multiply starting from 3 and then reduce 1 every time. 3 times 2 times 1. Okay, 3 times 2 is 6. 6 times 1 is still 6. The same thing goes for 4 factorial. Okay, so we multiply the numbers that we reduce starting from 4, reduce 1 every time. So 4 times 3 times 2 times 1, we have 24. Okay, with that understanding, now we are ready to answer this problem. That is, we want to write down the first three terms of this sequence, n equal to n factorial plus 1. So let's write down our first term somewhere up here. So what is our a1? Okay, a1 equal to, okay, 1 factorial, because n equal to 1, n factorial, 1 factorial, and then we add 1. And here we have, okay, 1 factorial is equal to 1. So we have 1 plus 1 equal to 2. Okay, that's we have it. That is the first term is equal to 2. How about the second term? That is a2. a2 equal to, we follow this rule or this formula here. That is 2 factorial plus 1. And we know 2 factorial is equal to 2. So that is 2 plus 1. That is, we have 3 there. Okay, it's crowded over there. So let's write down for a3 somewhere down here. a3 equal to, so we have 3 factorial plus 1. Right? And 3 factorial is equal to 6. So we have 6 plus 1. Okay, we have 6 plus 1 equal to 7. Okay, there we have it. This is our first term, our second term, and our third term. Now we are ready to list, okay, all terms of this sequence. Okay, starting from the first term, that is we have 2. Okay, then the second term is 3, the third term is 7, and so on and so forth, goes to infinity. Okay, that's the answer for this problem. Okay, now let's try this exercise here, this problem, and see whether we can solve it. The problem is asking us to write the 10th term, okay, the 10th term and the 15th term, meaning we want to write down the 10th term, that is A10, okay, term number 10. We are given the formula for the nth term. This formula, we just follow this formula and substitute, in this case, n equal to 10. So the 10th term equal to, okay, n square, in this case n equal to 10. So we have 10 square plus 4, right? So 10 square is equal to 100. Okay, plus 4 is equal to 104. Okay, that is the 10th term, term number 10. Okay, now the problem is also asking us to find the 15th term, okay, terms number 15. That means we want to find 15th term, that is A15 equal to 15 square plus 4. Now 15 square is 225, okay, and we have to add 4, is equal to 229. Okay, that will be terms number 15 for that particular sequence. How about this exercise? This example here, we have an given to us, an equal to n minus 1 over n plus 2. Okay, we are asked to write what is, okay, term number 5 and also term number 8. Okay, first we want to find what is a5, term number 5. So we just follow that formula, that is 5 minus 1 over 5 plus 2. Okay, now 5 minus 1 is 4 and 5 plus 2 is 7. Okay, that's term number 5. Now how about term number 10, that is what is term number 8, sorry about that. So we want to find term number 8, so we want to find a8. This is equal to what? Okay, we follow the same formula and substitute n equal to 8. So 8 minus 1 over 8 plus 2. 8 minus 1 is 7 and 8 plus 2 is 10. Okay, that will be terms number 8. Okay, let's proceed with this example. Okay, asking us to find the indicated term of the sequence. Okay, we are given the nth term of the sequence and we are asked to find what is the sixth term, that is A6. Okay, so we are going to substitute n equal to 6. So we want to find A6, right? So we just follow the formula. We have negative 2 to the power n, in this case equal to 6. So 6 minus 2. Multiply by 2 times n, that is n equal to 6 again, plus 1, like this. So we have negative 2 to the power 6 minus 2 is 4. And in this bracket we have 12 plus 1, we have 13. Okay, that is equal to negative 2 to the power 4 is equal to 16. Okay, 16 multiplied by 13, and that's equal to 208. Okay, that's the answer for this problem. Now for this one, we are given an equal to 1 minus 1 over n square, and we are asked to find what is term number 10, that is a10. So to find a10, again we substitute n equal to 10 in this case. So a10 equal to 1 minus 1 over 10, and then we have to square it. So in that bracket we have 1 minus 1 over 10. Okay, 10 over 10 minus 1 over 10 is equal to 9 over 10, and we have to square it. Okay. Now 9 square is equal to 81 and 10 square is equal to 100. Okay, this will be our terms number 10, that is equal to 81 over 100. In the previous example, we are given the what we call the formula for the nth term. Okay, and we are asked to find the what we call the certain number of certain terms for that sequence. But sometimes the formula for the nth term is not given, but instead we are given the sequence itself. Like in this example here, we are given the sequence 3, okay, 6, 9, 12, 15, and so on, right? And we are asked to find what is the general formula, or what is an in this case, all right? So we see our first term here, a1 is equal to 3. So we see the number 3, 6, 9. These are multiple. The numbers actually in this case is the multiple of 3. Okay. So to get 3 is 3 times 1. Okay. To get 6 is 3 times 2. Okay. 2 in this case is the value for n. Now to have 9, we multiply 3 multiplied by 3. This is 3 multiplied by 4. You see the pattern there? 3 times 5, we have 15, right? So for an, in this case, very clearly that an is equal to 3 times n, or equal to 3n. Now let's proceed with this example here. We are given this sequence, that is 1, we have 3, we have 5, 7, 9. That is the sequence of odd numbers. You see, this is a sequence of, let's write it down. This is a sequence of odd numbers. Right? Now the question is how to write an, okay, for this particular sequence. Okay. So to find 1, okay, this is the term here, 1, 3, 5, 7, 9, and so on, right? So to get 1, okay, by using n, we have 2 times 1 minus 1, right? Now for 3, we have 2 times 2 minus 1. Now for 5, we have 2 times 3 minus 1. Do you see the pattern? Now to find 7, by using n, we multiply 2 by 4 and then we subtract 1. Now to find 9, okay, by using n equal to 5, we multiply 2 by 5 first. Okay, that is for n, and then we subtract 1. Therefore, we conclude, okay, that in this case, formula for an is equal to 2, because every one of these numbers, they have 2 in front, see, 2. And the number in the bracket is actually n, right? Yeah. Okay, 2 times n. And then we subtract 1. Okay, so this is the general term, okay, or what we call an. Okay, the general formula for this sequence. The sequence of odd numbers, the formula for an is 2n minus 1. Okay, in this example here, we are given the sequence starting with 2 as the first term, and then we have negative 4, the second term, the third term is 6, and so on. We have negative 8, and then we have 10. We have to recognize two things in this case, okay, in this sequence. Okay, the first one is the number itself, that is 2, 4, 6, 8, and 10. Okay, they are multiple of 2, right? So we want to write down the general formula. Okay, the general formula for each term. That is what we mean there is we want to find what is an actually. So what is an? Okay. Yeah, the number is 2, 4, 6, 8, and 10. That is actually 2n. That is multiple of 2. But at the same time, we have okay, the sign positive and negative alternate to each other. The first one is positive, the second one is negative, and then positive again, and then negative, and then positive again. See, alternate positive and negative to each other. So we have to take care of that. And we write that down as negative 1 to the power. Okay. Now the first one is positive, right? See here, 2 is the sign of 2 is positive. So what we have to do is negative 2 and negative 1 have to power n plus 1. Okay. This is actually the way how to write down the nth term of this sequence. Now let's check whether this formula for an is correct or not. Okay, now let's try for the first term, that is a1. Let's check it out. A1, okay, that is we want to substitute n equal to 1 and see whether we get 2 or not. Okay, when n equal to 1, so we have negative 1 to the power 1, that is the value for n, plus 1, and then multiply by 2 times 1. This is equal to negative 1, okay, square, multiply by 2. Okay, this dot here, okay, the sign of multiplication. All right, so negative 1 square is 1. Okay, multiply by 2 is equal to 2. So we have the first term is 2. Is that true? Yeah, it is true. So our formula here, an equal to negative 1 to the power n, okay, negative 1 to the power n plus 1 multiplied by 2n, okay, is correct. Now let's see the next example. Okay, we want to write down the nth term or the general formula for the an. For this case, that is, the sequence consists of 3, okay, repeated goes to infinity. That is 3, the first term, the second term also 3, the third term also 3, and so on. Okay, 3 forever. So how to write down an for this term? Is easily written like this. An equal to 3, right? Yeah, because, okay, see this term, 3, 3, 3, each of this term is not depending on the value of n. Now, let's check it out. For example, we want to check what is a1. Okay, a1 is still equal to 3 because, okay, the nth term is not depending on the value of n for this case. Okay, a1 equal to 3. What is a2? A2 is also equal to 3, and so on. So this is the what we call the nth term for this sequence. Where in this case we are given a sequence consists of fractions. Okay, see all the terms here are all fraction: 2 over 1, 3 over 2, 4 over 3, 5 over 4, and so on and so forth. And you see the terms, they follow certain rules. You know, you have at the denominator, for example, we have 1, and then the next term the denominator is 2. Okay, here for the third term the denominator is 3, and so on. You see, and up here at the numerator we start with 2, and then 3 here, and then 4 there, 5, and then followed by 6, and so on. So they follow certain rules, certain pattern there. So how to write down the nth term? Okay, of course that should be in terms of fraction. See, down here we have 1, we have 2, we have 3. This is n, right? So an will be equal to, the denominator will be equal to n, of course. Now how about the numerator? Okay, we start from 2, and then 3, and then 4, okay, and then 5, and then 6, and so on. Of course, okay, the numerator consists of n plus 1, right? N plus 1. So an in this case is equal to n plus 1 over n. Now let's check, okay, our formula here whether this is correct or not. Let's see. Let's check this one. That is this one is a4. Okay, let's check our formula whether we get a4 equal to 5 over 4. Let's check a4. Okay, using the formula. So a4 equal to n equal to 4 in this case. So 4 plus 1 over 4. So 4 plus 1 is 5. And then we have to divide by 4. Okay, this is 5 over 4 we get. And the what we call the terms number 4 in our sequence here is also 5 over 4. This shows that our formula for an, okay, this formula is correct.